Median is the midpoint of the distribution. That means that it should be the point where half of the data points are below, half of the data points are above. Now, median does not care what the data points are below and above it, just that they are below and above that point. So what you'll do when you are solving for median is first you will take whatever data you have, and then you need to sort your data. Generally, we do ascending order, but it works just as well for descending order. Then what you're going to do is you're going to figure out how many data points you have. If you have an odd number of values, it's just going to be the middle value. So for example, if I have 21 data points, that means that it will be the 11th, 10 below, 10 above. If I have an even number, what you'll have to do is you'll actually have to go to the middle two numbers. So now let's actually look at an example, and then I'll show you how to find where that value is if it's an exceptionally large amount of data. So we're going back to our example where you have people with the waiting times at a restaurant. So our data points that we have are 14 minutes, 15 minutes, 14 minutes, 20 minutes, 15 minutes, 16 minutes, 13, 21, 14, 19, 20, and 25 minutes. So first thing we're going to do is I'm going to count them just so I know how many I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have a total of n equals 12 data points. And now what I'm going to do is I'm going to put these in order. So it looks like my smallest number is this 13 right here. So I'm going to write that one down first. 13. And then I've got 1, 2, 3 14s. So I'm going to write those down. 14, 14, and 14. Now, one thing I would suggest when you're doing this is maybe leave a little bit of space in case you miss a number and you have to come back, you can kind of cram it between. Okay, it looks like we have two 15s. So 15 and 15. And then the next number appears to be 16. And then I see a 19, two 20s, and then a 21 and a 25. Now I'm just going to double count these numbers just to make sure that I got the right number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It looks like I have all the data points. So what you could do, if you have a small amount of data like this, is you could just basically start at the two ends and come in, right? So we have these two outer values, the next one in, the next one in, the next one in, the next one in, and you get these two values in the middle. So now the question is, what do you do when you get to your middle two values if you have an even number of data points? Well, you just take the average. So this is going to be 15 plus 16 divided by 2, which is going to give us 15.5. So you can kind of imagine like you're putting an imaginary point right here at 15.5, where it'll split to the left half, 1, 2, 3, 4, 5, 6 of the data points, and to the right half, 1, 2, 3, 4, 5, 6 of the values. So this perfectly cuts the data in half. Now, if you had a large amount of data and you didn't want to have to try to move your way in, what you would need to do is you would need to count how many data points you have in, and then divide it by 2. So in this case, we would get 12 divided by 2. If you have an even number, then what you're going to do is you're going to count this many in, 1, 2, 3, 4, 5, 6. That'll be your first value. And because it's even, we know we also need to include the next value, right? Because you can kind of think of it as we could also count from the upper values, 1, 2, 3, 4, 5, 6. And this is why, like I said, with median, you can actually have it in descending order. It doesn't have to be ascending because this works regardless of which direction you come in. 6 of the data points are below, 6 of the data points are above. Now, the reason that median is so useful is because it splits the data by where half the data points are below and half the data points are above, giving us a really good indication of where the middle of the data is because it's not heavily impacted by what those values are. Now, the thing about this, though, is just like anything, it does have its shortcomings. Because it does not care where those numbers are, you might have one side where you have data that's nicely spread out, and you have on the other side of your median, maybe you have a lot of data points right here. And again, this can still be very important though, because this will show us that this is the point where half of the data points are above it. Now, really, the biggest reason why median is so useful is because it's not heavily impacted by outliers, right? It does not care if the data points are right here or if the data points are all the way out here, like this one is. All it cares about is that it's above and below. So an example of this might be if you're comparing something like mean, which is heavily affected by outliers, you oftentimes will get averages or means that are misleading. For example, if you look at the median household income in the United States, you're going to see a bigger number than if you look at the median household income, because the median household income is the point where half of Americans or people in the United States who count their income are lower than that value. But the mean household income is going to be pulled up because, again, we've talked about this before. Those people who make extreme amounts of money, those outliers, those billionaires, are pulling everybody up with them. And because they make so much money, and there's a hard cap at how low household income can go, because really the lowest value is 0. That means that you have a hard cap for how low the values can go, unless you're counting debt and you can go negative, but you have no cap to how high the values can go. Meaning that if you compare median to mean, median is going to be much more representative of where the middle of household earners is versus mean, which again is going to be heavily affected by outliers. So now what do we do if we have an odd number? So we have a much smaller example for this, but let's say you had the values 7, 12, 24, 20, and 19. So again, first thing you're going to do is you are going to order the values. And in this case, we have 1, 2, 3, 4, 5. So we have n equals 5 total values. So I'm going to put these in order. So this is going to be 7, 12, 19, 20, 24. And because n is an odd number, you could still divide it by 2, just like we did before, because you can divide either of them by 2. And this is going to give us 2.5. So if it ends in this 0.5, that means that you are going to go up to data point 2, and it's going to be the next one. So we would go 1, 2, and then our median is going to be the middle number, the next number. So you can see that median actually can have 2 different ways of being done. If it's even, you see how many data points you go up, and it is the average of that data point and the next one. Or if it's odd, you go up to the whole number, that many data points, and you go to the next one. That 0.5 tells you it is the next one. And that's kind of how you can tell, even if you're not really paying attention. If it comes to a whole number, it's an even number of outcomes. If you get a number with a 0.5, that means you have an odd number of sample size. Now, you might notice also, when we have an even number, we end up actually splitting the data sort of like with an imaginary number. It's the number that would split the data equally to the left and to the right. When you have an odd number, we're actually going to use that middle number as the median, meaning we have, in this case, 2 data points to the left, and we have 2 to the right. So this perfectly splits the data half above, half below. Thank you for watching. To continue learning, click the linked video here for the next lesson. If there's a topic you'd like me to cover, let me know in the comments. Don't forget to subscribe, and I'll see you in the next video.